Okay, so solving index equations. So the basic approach is to write everything in terms of primes. So what that means is if we have something that's like 9 to the power of x, then we can rewrite this as 3 to the power of 2 to the power of x, or just as 3 to the 2x, okay? So the idea is to change whatever our base is into a prime number, okay? And so we're going to be using that idea to solve a few equations. So we're going to solve these following index equations. So we're going to start off with A, which is 64 to the power of x is equal to 8 4x minus 5. Now you could, I should state by saying that the idea behind this is we want to get the bases to be the same, because it's only when the base is the same is when we can start doing stuff with these things. Okay, now in most cases, it's ideal to get them into the prime factors, okay, so those prime numbers. But if we can get one of the numbers in terms of the other base, so as in the 64, we know we can change it to an 8. It's worth doing that as well, but it doesn't hurt to change everything to a prime, all the bases to a prime, but it's not necessary in most cases. So in this one, 64 to the power of x, well, I can write that as 8 to the power of 2 to the power of x, and that's just equal to 8 to the 4x minus 5. Okay, and this is just the same as by doing my power of a power, 8 to the 2x, because I multiply those, and that's equal to 4x minus 5. Okay, so once I've done this, okay, now the bases are the same. I don't actually care about those at all. I just need the 2x to be equal to the 4x minus 5, because I need the those powers to be the same, because the bases are the same, now the powers need to be the same. So I'm going to rewrite the powers just as an equation, and we're going to solve this equation. So I'm going to start off by subtracting both sides by 2x, and I'm going to get 0 is equal to 2x minus 5. I'm going to add 5 to both sides to get 5 is equal to 2x, and then I'm going to divide both sides by 2 to get 5 on 2 is equal to x. Okay, and this is the solution that makes this equation up the top true. So if I put 2/5 into that, so 64 to the power of 2/5, and 8 to the power of 4 times 2/5 minus 5, I should get that both of those sides are the same. So we're going to do the same thing for this one. So we've got 1 over 25, okay, to the power of 6x minus 5 is equal to 5 to the negative 3x plus 2, okay? So 5 is already a prime number, so the 1 over 25 is probably what I'm wanting to change, okay? So having a look at this 1 over 25, well, I can see that's the same as 1 over 5 squared, okay, to the 6x minus 5, and that's equal to 5 minus 3x plus 2. Okay, and remembering from the previous video that anytime I have the 1 over, I can rewrite that as 5 to the negative of that power, or that index. And that's equal to 5 to the negative 3x plus 2, just like this. Okay, now that we've done that, I can do my power of a power rule, and I get 5 lots of negative 2 times 6x minus 5. And that's equal to 5 to the negative 3x plus 2. Okay, so 5 to the negative 12x plus 10 is equal to 5 to the negative 3x plus 2, which gives us, in return, some bases that are the same with the indices being different. Now with the same basis, we can rewrite the powers as the equation, because we want to find which value of x to makes both sides true. Okay, so we're going to write the equation like this. To continue, what we're going to do is I'm going to start off by adding 3x to both sides. I'm going to add 12x to both sides. So plus 12x, and that's going to give me 10 is equal to negative 3x plus 12x is 9x plus 2. And I'm going to subtract negative 2 from both sides. I'm going to subtract 2 from both sides, not negative 2. I'm going to subtract 2 from both sides, and I'm going to get 8 is equal to 9x. And then I'm going to divide both sides by 9 to eliminate the 9 from the right-hand side. And that would give us x is equal to 8 over 9 as our final solution. Okay, so as you can see, when solving these problems involving these equations with these, these powers, these different powers, and where the unknown is in the power, okay, it's all about the manipulation. Okay, so manipulate your values and manipulate your bases until you get something that you want, and then use your index laws and index rules to change for what you want.